This lesson is about finite geometric series. In the previous lesson, there's references to series all over the place that I crossed out. Okay, here's the relationship between the two. A geometric series is the sum of the terms of geometric sequence. Give me a pen. Okay, so terms could be like 1, 2, 4, 8. A series would be 1 plus 2 plus 4 plus 8. Okay, 8 would be T4. This would be S4. Okay, the series or the sum of the first 4 terms of the sequence. Stop resizing stuff. All right, so geometric series are pretty interesting, and this is a true story from the creation of the game of chess. Okay, so when Sissa ibn Dahir invented the game of chess, the king Shirham was so happy he granted Sissa any reward he desired. Okay, so you think, what would I desire if I invented a game of chess that pleases the king so much? And you might think Ferrari, $1 million, all these sorts of things. Okay, it was rumored that Sissa requested 1 grain of wheat for the first square on the chessboard. That's not very much. 2 grains for the second square, 4 grains for the third square, and so on. Each square being double the amount on the previous one. All right, so Sissa did all this work. Okay, made the game of chess. Okay, chess is a great game on Thursdays, lunchtime, library, area 3. And all he's getting is a bit of grain. I can go to Coles, get grain, $5. All right, let's say, that's interesting. All right, how many grains of wheat would Sissa receive for the 10th square? Okay, so we're all professionals at geometric sequences by now. Okay, so without having to do too much working, okay, I know for the first square, he gets, let's just write down our sequence so far. So 1, 2, 4, etc. Okay, how many does he receive for the 10th square? Well, I know that a equals 1. Okay, since T1 is 1. Okay, R is, well, let's do this properly. Looks to be 2. I better verify that with the next pair. This doesn't take long to verify. Yep, okay, sounds good. Okay, so my rule is the general term is 1 times 2 to the power n minus 1. So I want to know how much he gets paid. Remember, I could check that. I could find T3. Okay, checking's good. What does he get paid for the 10th square? Okay, so I need to find T10. 1 times 2 is about 10 minus 1. Okay, into the calculator. 1 times 2 to the power 10 minus 1. 512 grains. Okay, so he gets 512 grains for the 10th square. Pretty sweet. Okay, how many grains of wheat would Sissa receive for the first 10 squares? Okay, so this is really looking at what is the sum of the first 10 squares. And for the moment, we're fine to do that just manually. Okay, let's just write down the first 10 things in our sequence, okay, which will make our series. 1, 2, 3, 4, 5. I remember just all the iPhone capacities and MacBook hard drive sizes. Okay, we can just add those 10 together. Okay, go to our calculator. Hopefully you've got a keyboard to be able to do this as well. Suckers. Hopefully no errors. 1,023. Okay, we get 1,023 grains. Okay, for the first 10 squares. Okay, so we know what S10 should be. Okay, what we're shown in this big box is the development of a formula for finding the sum of n terms. Okay, so if you're like a Maths B guru, Maths C student, sure, go ahead, read through this. Otherwise, you're happy just to accept this rule down the bottom will be the sum of m terms. Okay, this development just shows it through simultaneous equations. Feel free to have a read through. If you've got any questions, you can ask me, I'll talk you through it. Okay, but we really just want to be using this formula. Okay, so a series of n terms is found by getting the first term, multiplying it by 1 minus the common ratio to the power n, divided by 1 minus r. Okay, so let's have a look, see what we can do. Remember, for our rule here, we had a equals 1 and r equals 2. Use this formula to find the number of grains of wheat Sisler receives to the first 10 squares. So let's have a go at finding S10 using this formula. 1 times 1 minus 2 to the power 10 divided by 1 minus 2. Okay, and I'll go to my calculator, put all this in. Probably need some fraction action. Get 1,023 again. Okay, too good. Okay, so what that shows us, I guess, in a sort of weak way, is that this formula is okay. This formula works. Okay, as a way of adding lots of terms in a sequence or finding a series. Okay, so that was interesting. What we're really probably wondering in this problem is, well, how many grains of wheat does he receive for the whole board? How many... I need a picture of a chessboard on this slide. Yeah, that's our chessboard. There's 64 squares. Okay, so we're going to need to find S64. Okay, so the same formula. The only thing that's going to change, okay, is that power. Okay, I'll just highlight where the change is. I should be doing this highlighting all the time, just to show where the substitution is. Technology. Alright, so just, if you can't do this, you need these skills. So I just want to change that power to 64, so I arrow up, then I press across, and I'll be able to get in there. Not that far. Now I can delete that 10 and replace it with a 64. Whoa, enormous number. 1.84 E19. E plus 19. Okay, if you ever write that on an exam, I'm going to give you detention, okay, because that's bad. Okay, this means 1.84 times 10 to the power 19 grains of rice. Okay, that's your calculator's way of showing scientific notation. Okay, which would mean I need to move the decimal place 19 places to the right. Okay, it's a really big number. So 1, move it 2 places to 8, 4, and then I need 17 zeros. If I wanted to write it as a proper number. That's a lot of grains of rice, probably more than exist in the whole universe. Okay, what number is that? No idea. Okay, type it into Google, see if it tells you what number it is. Millions, billions, trillions, heaps. All right, that's a lot of grains of rice. Okay, what if he wasn't happy? What if he thought, oh, I've stuffed it. I should have made more than 64 squares. I could have made heaps more cash or heaps more rice. And maybe his goal was to get 10 to the power 30 grains of rice. So 1 followed by 30 zeros. I don't think I can delete anything on these videos. Oh well. Okay, how many squares? Okay, so what it's really asking is, what does n need to be for Sn to equal 10 to the power 30? Okay, that's really what the question's asking. So let's have a go. All right, so I know my formula for the sum. And I'm going to sub in all the things I know. Okay, so sub in Sn equals 10 to the power 30. I still know that A is 1 and R is 2, and hopefully I'll be able to solve for n. Let's give this a go. So 10 to the power 30 equals 1 times 1 minus 2 to the power n divided by 1 minus 2. Okay, so I need to solve this. Probably good to simplify a little bit before I solve. The 1 times I don't need to write at all. 1 minus 2 is minus 1. Okay, so I'm going to multiply both sides by minus 1. Get minus 10 to the power 30. 1 minus 2 to the power n. Okay, moving up here to continue. I'll just to be systematic, I'll subtract 1 from both sides. So minus 10 to the power 30 minus 1 is minus 2 to the power n. Okay, I'll divide both sides by minus 1. Okay, and then I can convert this to a log statement. Where'd my work go? So n will be what I raised 2 to in order to get this number. Okay, let's have a look at what it gets. Log base 2 of, probably put a fraction in here, minus 10 to the power 30 minus 1 divided by minus 1. 99.65. 99.66. Okay, since he can't make a fraction of the board, and since the number of grains is increasing all the time, okay, since the sequence is increasing, he would need 100 squares. Okay, have a go at these problems. keep in mind the general idea is trying to find A and R values to be able to use these general formulas. There's a few pretty tricky problems in there. Definitely have a go at one Hij, and then we can have a look at the underlying modeling problem solving questions that you can't get in class together. Okay, bye.